Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to reveal the project that I've been kind of leading up to in the last couple of videos. Take a look at this very short video of this project in action. About a month ago, there was a video circulating on Facebook credited to a man named Dennis Hartman. I'm not sure if that was Dennis in the video or if it's a video he found and shared, but it is on his page on Facebook. Several folks shared that video to my Facebook page. And several other people linked me in the video where he had been shared on other people's pages. So I kind of took that as a challenge. As I've said 100 times before, I live out in the country. There's farming around here. We haven't raised a garden in several years, but we haven't processed a lot of sweet corn in the last few years. But over the years, we did. We bought, or a friend of mine used to give us corn every year, and we'd put up anywhere from 75 to 100 dozen ears of corn. Now that would be split between 3 families. So, but it was very good, but very labor intensive. And so I kind of put this project together in the hopes and desires that we can start putting up some corn again, can find some local sweet corn and put up, but also that my neighbors can use it, especially the one that used to give us corn every year. He would call me and say, Lee, we're done in the corn patch, come get all you want. And we did. And also I've got a nephew that's promised to raise some corn for me next year if he can use this. There's a link to all the material. I do not have a set of drawings or a plan for this, but there's a link to all the materials used in the description below. So be sure to look at that description if you're interested in building it yourself. Each item that's on here is listed in there. I do have one small drawing of the cutter that's used in here. I'm going to zoom you in a little bit closer and point out a couple various items on the cutter itself or on the cutting machine. The power behind this project, of course, is in this air ram. And my 2 previous videos, and I will link them in the descriptions as well, but one of them was simply laying out the bolt hole patterns to mount this air cylinder, the control valve, and the regulator that's back here on the back. In my last video, I actually showed hooking up the air cylinder, doing the plumbing, and what each port on the valve stood for. In addition to the pneumatic part up here, the power behind it, we have a cutter down here. We have a pan to catch the cut corn in. Underneath the pan, I put a stem, if you will. That stem is made to fit perfectly inside this bundt cake pan. so that every time this is set back down, it comes to the same spot. I added some hooks on the side to hang the pans on. I put 2 pans with this unit so that while this one is being emptied and cleaned out, the cutting process can go on. Over here on this side, I've got some hooks for tongs to hold the corn and spoons just to rake it down. On the bottom down here, there are small adjustable feet, like you'd put on the bottom of a chair, adjustable gliders. Let's talk a little bit more, or let me show you a little bit more about the cutter. To make the cutter itself, we're going to be using a piece of food grade stainless steel, 304 stainless steel. This is 1.5 inch outside diameter, 1.25 inch inside diameter that the cob will slide through, and overall length is 1.9 inches. Now, I made a prototype out of aluminum, and here's just a crude little drawing or dimensions of the cutter. As I say, the overall length is 1.9 inches, 2 inches. This is all plus or minus 10 thousandths. Outside diameter, outside diameter 1.5. Major outside diameter length, which is this area right here, will be 0.65. The ID is 1.25. The seat, this area right here, will have a diameter of 1.4 inches for a length of 0.5. The cutting edge itself will have a length of 0.75 and will put an angle of about 9.5, 10 degrees. And what that will do is bring this down to a sharp edge. We want that, pretty sharp. It needs to cut the corn. All right, so I'm going to mount our piece of stainless in the mill vise now, or in the lathe chuck. And what I'm going to do is, here on my compound, it'll be much easier to cut this from the back side. So I'm going to slide this back to the back side and set this up for about 9.5, 10 degrees. Now I need to turn the tool post perpendicular to the workpiece itself. I'm just going to basically line the tool post up with this edge right here. Now, carriage, we're going to lock it down in place right here. We're going to put the lathe in reverse. We're cutting on the back side, so we put the lathe in reverse. Now, we got the cross slide, the cross slide locked in position right here. I'm just pulling the compound in, I don't know, 30, 40 thousandths for each cut. And I think I need to advance that point on that insert. All right, let's see how that does. Still not getting as smooth a cut as I'd like. I'm going to turn this on around just a little bit. As long as the compound is still at the same angle, everything will be fine. Now, I'm nowhere near as concerned about this 3/4 inch length here as I am watching this edge over here for it to come out to a nice sharp edge without rolling the edge. All right, that need to look right quick. That's a pretty good edge right there now. I'm going to come in about 10 thousandths and very slowly bring this back out. And without advancing the tool at all, I'll go back in again, just making a spring pass. Okay, I suspect that's a little bit warm right now. But I'm going to turn this around in the lathe and bring you guys right back. So we want to take this seat, what I'm calling the seat here, we want to take it down a ½ inch in depth down to 1.4. So I'm going to zero out the DRO right there, come in a ½ inch, and as you've seen me do hundreds of times before, just put the carriage stop in place. Now let's touch off. This outside diameter is currently 1.5. We want to come down to 1.4. That's 100 thousandths. So I'm going to come 60 thousandths in this first cut. All right, now let's get a measurement on that. 1.449, so we need 50 more thousandths to go. That's about as close to 1.4 as I think I can get. What I want to do now is just ease this edge. This is just a exit for the cob to come out here. This will seat down in the pan. But there we have our cutter. Now this bundt cake pan didn't come quite like that. It had a big hole in it, but not quite this big. For the catch pan, I decided to go with a bundt cake pan instead of a sponge cake or angel food cake pan, primarily for two reasons. Number one, remember we got to get the cutter seated down in, and this bundt cake pan has a much larger ring up here that I can machine out that this will fit down into. Whereas the angel food or sponge cake, much smaller and nothing really to the machine. I would have had to cut it off in length and find just that exact spot to cut it off for this diameter to fit in and this shoulder to set on it. And the second reason I didn't particularly care for the sponge cake pan was they normally come in two pieces. And that's just more area up under there and under here for food substance to get trapped in. Remember, this is an item for dealing with food, edible food. And so this appeared to me much easier to clean out than the sponge cake pan, and much less likely to trap food in it. I'm going to get this mounted down on the mill, then put the boring head in, and we're going to bore this out to where that will set down in there. Okay, I've got the pan hopefully secured down to the table good. I've got the boring head in now and got it centered. And I'm going to take this nice and slow. I'm at about 220 RPM. I've left the boring head high enough so that we can test this all along and not have to move the height. So let's get a... And I don't want to keep tightening this down. I don't want to bend the handles, but that did loosen up just a little bit. So we're just going to take this nice and easy. All right, I'm going to have to do something different on this clamping. Okay, I've come back now, and instead of just 2 points of contact, I got 3. And I also took some of this toolbox liner, rubber type material, and put between the mill table and this non-slip or non-stick surface. So let's see if that'll do a little better. And I had to recenter it, which I did. And I sped my RPM from 220 up to 320. I believe it'll work a little better with a little faster RPM. Alright, there we go. Okay, I got a little deburring to do on that underside under there. But the cutter should have a good solid surface to set on now. I did not try to video the welding of this frame, of putting it together, as that's pretty much self-explanatory. And again, the dimensions of all this are in a material list that's linked in the description. One of the most important parts of putting this together, though, was to be absolutely certain that when this ram comes down, it comes down in the center of this cutter. And as we talked about with the pan, that stem makes certain that the pan goes in the same spot every time. Let's take a quick look at video of just how I made absolutely certain that this ram will come down in the center every time. Alright, I've got the frame sitting on the welding table now, and I've got the cross member for the cylinder clamped in the top. I have it flush on the top up here as best I can feel on the sides, both sides, got it flush. But it is absolutely imperative that this ram come down in the center of the pan base here. This is the base that the pan will set on. I went to the lathe and took a piece of 1-inch aluminum, drilled and tapped it for number 10 by 1.25 metric thread, and also turned a point on this end. I want to bring the camera up close so that you can see the lineup. I've got a witness mark here of where the actual center is. Okay, this dark point right here is the center. If we bring that pointer down, we'll see we're off about 200 thousandths in what we'll call the y-axis, and just a little bit in what we'll call the x-axis. So I'm going to tap up here on the top. Alright, that's got it lined up on this axis. Again, we're calling that the y-axis. So now I need to tilt it just a little bit. To do that, I'm going to hold a screwdriver on one side and tap on that other side. Alright folks, I think that's about as close as I can get it right there. Okay, I have the what we're calling the pan seat mounted in the mill vise now. And remember, we talked about how important it was that that ram come down in the center of this piece on both the X and the Y axis. I have a witness mark here. Just as important as the ram coming down on that center is that the pan and cutter line up in the same spot every time. If it don't, when the ram comes down here, and hits this cutter, it's going to destroy the cutter or bend the ram in the cylinder and so forth. So I have this lined up. I have my drill chuck lined up on that center. What we're going to do is drill a hole in here, basically the same size or a little larger than our cutter, which remember is 1.25 on the inside. The outside diameter here was 1.4. Now I debated in my head hours on how to be sure that pan gets seated in the same place every time. Because you're cutting corn, after a while, this pan's got to be emptied. And another one set in, or this one brought back and put back in there. And it's got to line up. And it's got to stay still. With the movement of the ram back and forth, we can't have this vibrate. It's got to be in the same position every time. And again, I debated over and over in my head how to assure that. I even went and purchased this piece of 1/4 inch plate here. Thought about welding that down to here and putting some kind of stops on the side over here to be sure that pan goes in the same place every time. I just didn't like that idea. I'll find another use for this one day. Then it hit me, why not make something that'll go up in the pan here and be stationary, fit the inside of the pan. So I come up with this sleeve, and this is not a food grade stainless steel. The only thing that's going to go through here is the cob. This fits in there snug and is the same height as the bottom of the pan. So if that's sitting in there, if we get this in place, centered in place, welded down, then every time we put this pan back in and out, it's going to come to the same spot. We'll set the pan in, we'll put the cutter in, run our ears of corn through it, pan gets full, remove the cutter, and lift this, empty the pan. So what we need to do is bore a hole in that, the same diameter of this as the inside of that. Remember, the cutter is actually sitting down in that. This was 1.4. I made this about 1.45, something like that. So that's what we'll shoot here is 1.45. Then we'll center this up, tack welded in 4 spots, dead centered over it. Okay, apparently I forgot to turn the camera back on, but after we finished drilling that with the 1-inch drill, I put the boring head in and bored that out to just a little over the 1.4. Now what will happen, we'll take this stem right here, I'll get this down where I can see clearly in there, line that up and put 4 tacks all the way around it, just hold it in place. Then each time the pan is removed and brought back, it'll set on this stem. It can't move on the stem. It was made to fit exactly the right height and diameter. So we'll set the pan back on the stem that is held in place, that is solid. Cutter goes in there, we cut our corn till the pan's full. We remove it, empty the pan, come back, and it'll be in the exact same spot every time. Now I'll do it off camera, but I'm likely going to make a couple spares of these cutters, just in case it gets dropped on the floor. You know, all it would take is dropping this on the concrete floor, and it would be bent and pretty much useless until it was turned back down again. So off camera, I'm probably going to drill and bore a couple holes over here, just somewhere to store some extra cutters. One of the things I noticed in the video credited to Dennis, and I'm assuming it is his video, and if it is, I'll give him full credit for this idea of me getting the idea of making this. But one thing I noted in his video, he had the control valve such that you pushed it forward, pulled it back, push forward, pull back to control the ram. Now if you noticed in that short little video at the beginning of this clip, I was using my left hand to pick up the corn and place it over here. And I was using my right hand to control the valve. I'm left-handed, and it takes considerably more dexterity with the corn hand than it does the valve hand. The valve hand, you just got to push it and pull it back. Whereas the corn, you've got to get over here, pick it up, place it in the cutter, hold it pretty straight, back off if you need to, straighten it up. So I did something a little bit different. I mounted my valve on what we'll call the x-axis, so that you push it in for the valve to go down, pull it back for the ram to go up. That's because, again, I'm a left-handed person. A right-handed person using this would simply set on the other side or turn it around. If it's turned around, then I can use the right hand to pick up the corn and the left hand to control the valve back and forth. So, as I say, I pretty much designed this for myself because I am left-handed. But as I said earlier, I want this so that some friends and neighbors can use it, and I'm sure most of them will be right-handed. I know this is not a project that a lot of you will need to duplicate, but there may be a few of you out there that process corn and might want to build something similar. I'll tell you right off the bat, if I was going to do one again, I would go with a shorter cylinder. This is, there's no need of this 18-inch. I could have probably got by with a 14-inch, possibly even a 12, just according to how big the corn you normally process is. Again, I hope you enjoyed it, and stick around another minute and I'll show you a little blooper, because it don't always do like you want it to do. Take care, and I'll see you on the next video.